Hello, Calc. There are a couple topics I want to cover before we review for the year. And the topic that I want you to be aware of before you go on in your math life, especially if you take another calculus course anywhere else in your life, there is a topic that I would like to make sure you've seen. It's called integration by parts. So it's a type of integration we use for certain expressions we have no other way of integrating. Alright, so I'm going to start developing this by reminding you that the derivative of a product, so I want to say, that's one way of saying it, d dx of a product, u times v, equals the first times the derivative of the second plus the second times the derivative of the first. Often u's and v's are used when you study integration by parts, and I know they're kind of aggravating, and when you write them sometimes I just make sure that my v's are extra pointy and my u's are extra rounded to make sure you can see the difference clearly. Alright, so I'm going to multiply through as if the dx was an algebraic quantity and just leave off that. So I'm going to have the derivative, or the differential, it's called, of d of uv equals u times the differential x. Already messed up with my u's and v's. The differential of v plus v times the differential u. Alright, now I'm going to continue messing with this by taking the integral. Over here the integral of a sum is the sum of the integrals, so I end up doing that. On the left we have the derivative, an integral of a derivative, which is just uv, and here we have the integral of u dv plus the integral of v du. Alright, I'm going to rearrange that, and I'm going to move this to this side. So I have uv minus the integral of v du equals the integral of u dv. And now I'm just going to put this on the left and this expression on the right. The integral of u dv equals uv minus the integral of v du. This is the rule for integration by parts. Interesting, it just started with the product rule and we just sort of rearranged it. So let me show you how to use that with a problem. Suppose we are asked to find the integral of x sine x dx. So the methods that we know so far, like u substitution, if you say this is u, the derivative is du, it's cosine. If this is my u, du would be cosine, which doesn't exist. So if I say this is my u, then du is 1, and we can't catch this. So there's no real method that we have so far. So integration by parts will come and save the day. So I'm going to write that formula again. And I am going to create a box, and there's going to be a u side and a v side, and a du and a dv. So this is my spot where I'm going to pick u, v, du, dv. Now, when I'm using integration by parts, I'm going to choose a u and a dv. So I'm going to fill in on this diagonal, and I'm just going to assign it. So I have an x and a sine x. I'm going to make one of these, so this is going to be divided up between u and dv. So I could say that u is sine x and dv is x dx. Or I could say u is x and dv is sine x dx. It doesn't matter if you choose in the wrong way, because you can always do it again. So let me pick this way. Let me say that u is going to be x. So I'm gonna, it doesn't have to line up correctly. It's not what makes it correct. But after we do one, I think you'll see how to more easily or wisely choose u and dv. And I'll use this to be dv. In the dv box, there should always be a dx. Alright, so now I have to calculate this box and this box. If this is u, what is du? It's the derivative of that, so it's just dx, 1 dx. And what is the integral? I have to go from dv to v, so I'm going to have to take the derivative to go that way, take the integral to go that way. So the integral of sine x is negative cosine x. Alright, so how do I know if I've chosen correctly? So I did notice I filled in, or I am able to substitute everything in this problem between u and dv. So I chose x for u, and dv is sine x dx. Alright, this is chosen correctly if this yields a, right, this I could not integrate, but if this formula over here on the right yields an integral that I can do, then I've chosen correctly. Alright, u times v is x times negative cosine x minus the integral. So here is the moment of truth. If I put in v and du, does it give me something I can integrate? I have minus cosine x, and on the du I have dx. Can I integrate that? Yes, I can. So I've chosen well. So this was a minus sign here, I believe. So x times minus cosine of x looks like that. The integral of cosine is sine. We have a double negative here causing a positive. So I just have sine x plus c. This is the answer to my problem. Let me show you one more, and then I'll let you experience these in class. Alright, so I'm going to do the integral of x e to the 2x dx. And you get used to knowing what an integration by parts problem looks like. I would think to myself, if u is 2x, then if u is 2x, du is 2, and I have an extra x here, so I could put in a 2 and a 1/2 to adjust for it, but that x is extra. But I could substitute u over 2 for x. Actually, I could do this one by u substitution. Let me try. Let me just try. Alright, so I can rewrite this as u over 2 equals x. So I can put in u over 2 and e to the u. And that 2 comes over, across the integral sign, u e to the u. And this 2, I need a 2 for my du. So if I put in a 2, so this is 2 dx. If I put a 2 here, that makes me put another 1/2 out here. So that 2 dx becomes my du. So guess what? I still can't integrate that. So integration by the normal methods that we know is not healthy. So we're going to go ahead and do it by integration by parts. So let me write it again. X e to the 2x dx. And the formula that we're going to use is the integral of u dv equals u times v minus the integral of v du. Alright, so I have to choose. And again, this is u, this is the v, this is du, and this is dv. So I'm going to choose x and my e to the 2x dx. How do I know? I don't really know. I'm just going to follow my nose and see if this leads to something. Do you see how I substituted this for u and this for dv? So now I have to calculate the derivative of this, which is dx, and the integral of that. So the integral of e to the 2x dx is, let u equals 2x, so du equals 2 dx. So I need a 2 in here, and I have to put a 1/2 out there. So with u substitution, the integral of 1/2 e to the u du is just e to the u, 1/2 e to the u. So we get 1/2 e to the 2x when we substitute back. Alright, so the moment of truth is when we plug it into this side on the right, if we create a new integral, which we can integrate. We couldn't integrate this. Let's see if we can integrate this. U times v as this times that, x times 1/2 e to the 2x, and minus the integral of v, 1/2 e to the 2x times u dx. Alright, so simplify over here. I'll do 1/2 x e to the 2x. Alright, can I integrate this? I can. It's actually a repeat of this over here with an additional 1/2. So I'm integrating e to the 2x, which is 1/2 e to the 2x plus c. Alright, can we clean it up? Let's pull out a 1/4 and an e to the 2x out of both these terms. See if that helps. 1/2, if I pull a 1/2 out of this, I get a 2x, and if I pull out 1/4 e to the 2x, I get the whole thing comes out. So minus 1. So that looks a little cleaned up a little. Alright, integration by parts. This is the formula that will save the day. Alright, you can work on that tomorrow in class or very soon. Till then, carry on.